Hello everyone, I'm going to calculate the barometric weather graph. So it's currently 9:98 past 20 hours. Each pixel is 2 hours on my watch. So I'm going to demonstrate how to calculate this on the watch using integral function on a Casio calculator. So the past 20 hours, let's make B 20 0, and it reads 998. It's 19,960. So as y'all can see, so that's the partition. So let me write that down. Integral, actually function. For 20 hours. Z, so it's going to be like, something like this. It's going to be integral BA f of x dx. So we get 19,960. Sorry about the shadow. You divide by 20. And it verifies 998 hectopascals on my watch. Okay, if you were to graph that, so let's see. So that's the input function, input of that, dx, so it corresponds to this as a verification. So if you look on the watch, some calculus right here. So if you see the past 2, 4, 6, 8, 10, 20 hours. So technically, if it keeps going down, we're going to have a storm. And then, yeah, so this is like the timer. If you want it to tick. But yeah, it's measuring the barometric pressure, so it's under 3. If this second hand keeps dropping, indication of a storm. And how this basically looks like on a graph, it's doing something like that, area under the curve. So we will shade something like this. That's the 20 hours right there in the graph that went by, and this is the other part. So yeah, you only, for the Y is 20 and the X is 0. So currently it's 998. That's right here. Right there. So basically this was at one point maybe 999. Probably like 1,007, 1,006. Yeah, sounds about right. Because basically, that's the deviation. It went down. So yeah, that's how you can use calculus. Basically to like verify that barometric pressure. And this scans every 2 hours. I forgot to include that. So every pixel on the graph of the watch is every 2 hours. That's the reason why I'm using, that's how I got 20 hours. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You add that to the B, or the y-axis. And then the A is 0. That goes into that. You plug that in, it verifies that. You get this. Divide by that 20. Right here. And you get the air pressure right there. So you see, yep. Integral 20, 998. 19,960. Okay.